In the PowerPoint on Units and Math, I showed you how to do conversions between metric prefixes using conversion factors and dimensional analysis. In this PowerPoint, I'll show you an alternative method based on the decimal system. So the metric prefixes are all based on powers of 10. As we discussed before, each prefix represents a different power of 10 multiplier to the base unit. When we use conversion factors to convert between prefixes, essentially we're multiplying or dividing by a power of 10. And since the decimal system that we use to write numbers is also based on powers of 10, this means that when we do a metric prefix conversion, essentially all we're doing mathematically is moving the decimal to a new location. The trick is knowing which direction and how many places to move the decimal. It turns out that we can set up our metric prefixes as a number line in decreasing powers of 10. Here are the most common metric prefixes set up from the largest to the smallest power of 10. Kilo is the largest, and it is equivalent to 10 to the third of our base unit. Hecto comes next. We decrease our power of 10 by 1, so that's 10 to the second of our base unit. Deca is 10 to the 1 of our base unit. And our base unit actually doesn't have a prefix. It stands in our number line for 10 to the 0 place, or 1. On the other side of our base unit, we start getting smaller, and we go into the negative values for our exponents. So deci is 10 to the negative 1 of our base unit, centi is 10 to the negative 2, and milli is 10 to the negative 3. Now this is just based upon our definitions of what these base units stand for. As long as we can remember this order in our number line, that's really all we need to know in order to move the decimal. We don't necessarily need to remember all of those powers of 10. I can remember this particular order pretty easily because I have a mnemonic which helps me do so. So my mnemonic is King Henry doesn't usually drink chocolate milk. Now you might have your own system for remembering the order of the metric prefixes. If you do, please make sure that you share it with us. Any tool for remembering these prefixes is great to know. Anyway, when the prefixes are written in this fashion, we can use the order to determine the direction and number of spaces to move the decimal for any conversion. Let's look at an example. We want to convert 2.5 centimeters to its equivalent value in meters. To figure out how many places to move the decimal and what direction, we're going to find our starting prefix on the number line. So that's the prefix associated with the unit that we're given. So that's centi. This is where we're going to start. Next, we're going to find the unit that we want, or the prefix associated that we want for our final value. So we want simply meters, which does not have a prefix, so that corresponds to our base unit. Next, we'll count how many spaces it takes us to go from our starting unit of centi to our base unit. So we go from centi to deci to our base unit. So that's 2 spaces. And that's 2 spaces to the left. We're going to move our decimal in our number, the same number of spaces, in the same direction. So we'll take that decimal and we'll actually move it 2 spaces to the left. That's going to be our new location. And we'll fill in any of those spaces that need it with a 0. So that fixes the location of that decimal. And our value in meters for 2.5 centimeters is 0.025. Let's look at another example. This time we want to know how many centimeters in 36 kilometers. Again, we start with the prefix that we're given, which is kilometers, or K. We find the prefix that we want to convert into, in this case centimeters, and we count how many spaces between kilometers and centimeters. So 1, 2, 3, 4, 5 spaces, and we moved to the right. That's the same number of spaces and the direction that we're going to move our decimal point in our given number. Now in 36, we don't have a decimal explicitly written. In these types of cases, you can always assume that the decimal is at the end of the number, in this case after the last number given, which is 6. And you move the decimal from that location. So 1, 2, 3, 4, 5. And I can fill in each of those spaces with zeros to mark the new place for that decimal. So 36 kilometers equals 3,600,000 centimeters. Here are a few points to remember about moving the decimal. First of all, you can only use this method when you convert between metric prefixes for the same base unit. That means you can move the decimal when converting between kilometers to millimeters because they both have the base unit of meters. If the base unit is different, though, you have to do the full dimensional analysis with conversion factors. For example, if you need to convert from kilograms to milliliters, you have to find the relationship between kilograms and milliliters for the substance you're dealing with. The base units are different here, grams and liters. And this relationship varies from one type of matter to another and is not necessarily based on powers of 10 alone. The second point to remember is that you can actually expand the number line to include other prefixes. Just remember that outside of the 6 that we started with in our King Henry mnemonic, the most commonly used prefixes are usually larger or smaller by powers of 10 to the third or 1,000. For example, the next largest unit after kilo is actually mega, which is abbreviated with a capital M. And the mega prefix is equivalent to 10 to the 6th of our base unit. This is 1,000 times larger than our kilo prefix, which is 10 to the third. To denote this appropriately on our timeline, we leave 2 spaces in between kilo and mega, and we count these 2 spaces the same as we would any of the other prefixes when we're doing our decimal moves. On the smaller end, the next smallest unit after milli is the micro unit, which is actually abbreviated with a Greek letter, the Greek letter mu. And then beyond that, we have the nano unit. So micro is 10 to the negative 6 of our base unit, and nano is 10 to the negative 9. And again, these are 3 spaces apart, or 3 powers of 10 apart. So we leave 2 spaces in between each of those units so that we have the appropriate number of spaces to move our decimal. And then we can use this number line to convert between even larger and smaller units. So we can convert between 4 microliters, for example, and milliliters. So our starting prefix is the micro prefix. We're converting into milliliters more specifically. So in order to go from micro to milli, I have to move my decimal 1, 2, 3 places to the left. So that's what I'll do on my number here. Now 4 doesn't have the decimal explicitly written, but we know it's going to be at the end of the number, immediately after the 4. So we start there and we move 1, 2, 3 places. That's going to be our new location for the decimal, and we fill in our blanks with zeros. So 4 microliters is equal to 0.004 milliliters. In summary, you can convert between metric prefixes by moving the decimal place on the measurement that you start with. You use a number line of prefixes in order from largest to smallest to figure out the correct places to move and the direction. And this method only works for prefix conversions with the same base unit. If you have different base units, you have to use dimensional analysis.